Okay, so we are the telescope simulator and commander team for the IBM Cognitive Telescope Network. I'm John. I mostly worked on the commander server portion. This is Dustin. He worked on the commander client. And then Nick and Afsana worked on the UI application. So the Cognitive Telescope Network is essentially a mission by IBM to build a network of amateur and college telescopes that will be able to capture transient events that are happening just throughout the universe. So right now, events are going on, comets passing by, that no one is really looking for, so we can't really find information about. So the goal is to have telescopes that are watching, they can see something happen, and then direct other telescopes to look and gather data about it. So we built the commander in the simulator that will essentially allow AI and users to directly command and maneuver telescopes that are not currently internet connected.
So there were basically three parts in our project. So one was the UI application, which the user would be talking to actually. And then for the back end of the project, we had the commander service and the commander device. So commander device is supposed to actually go locally with the telescope, but we have our telescope simulator right now, and that's a local thing with the telescope simulator. So what the commander device does is it actually gets data from the user interface, the commands from the user interface, and it executes the commands through the telescope simulator. But to do that, it has to actually get the data in a form and then package the data in a form of the ASCOM, which is actually astronomy standards for telescopes, and then it executes the command and it gets back the state of the telescope, and it has to pass that upward to the user interface, which actually goes to the IoT server. So then there is the commander service, which is actually talking to the database, then the IoT server, which we are implementing in our project, which is at the middle of everything. So if you want to see in the poster, so there is the IoT platform, and I'm talking about the commander service here. So the commander service gets the command from the UI to the APIs, and then it sends the command to the IoT platform. Then it goes to the commander client, and the commander client executes the command. And what the user application does is it actually gets the command from the UI, from the user, and sends them in a specific format to the commander service. So the technologies we used in our project was mainly the IoT platform, which was the meeting point of all the sub parts of our project.
The hardest challenge was communication with this project. This is a completely programmed project, all software, so it's a lot of individual work, but all of our components need to work together, and it was a lot of meetings, a lot of time spent testing where we couldn't do it individually. We had to do it as a team, and cooperation was really key.
I think one of the big things we learned in product development is that sometimes you just need to up the frequency of your meetings. As much as it may be tough to meet multiple times a week, sometimes you just can't get it all done working one night a week. And definitely working together is really key in making sure your product can meet its goals and meet your requirements. I think that was one of the big things that helped us meet those requirements and actually get our product finished.
Okay, so starting off, we have the UI application right here. So this is the main website that the client will use to manipulate a telescope. So, for example, we can change the right ascension and declination here on a telescope. So I'll go ahead and do that. So I'm going to have the telescope slew to these coordinates. So if I click this, essentially what's happening there is that an HTTP call is sent to our commander server. That is forwarded to the IBM IoT platform, and then that IoT MQTT call is sent to our commander client, which is on a telescope. So you can see in our simulator for our telescope right here that the command was completed, the slew was complete, and there's a new position on the telescope. And then another big thing we can do is take a picture on a telescope. So I can send a command to take a picture with an exposure of, let's say, 1 second. So I'll take that picture. You can see that the telescope just took a 1 second image right here. You can see a pop-up image is ready. So then we click Show Captured Images. There's a list of images associated with this telescope and camera. And then we'll click the most recent one and see that this image was taken.